Periodic functions are extremely important in grade 11 math. But before we move on into learning too much about them, we first need to understand a little bit about their key features. So that is what we're going to learn in this tutorial. Let's get started. So here I have three periodic functions. Periodic functions is just a function that has a certain pattern that repeats over and over and over and over again. And there are certain properties that we can identify with them. We have maximum and minimum value, their amplitude, period, and then of course we can use domain and range as well. So let's go over what these are for each of these three examples. So for the first one, maximum value, that's just going to be the highest value we have on our y-axis, which is up here in this example. It's hard to see, but 4. So that's 4, this is 2, and that is 0. Okay, so our maximum value for our first example will be 4. Minimum value, that's our lowest value. That's down here, right? For these points, that's our minimum value, so 0. Now the amplitude would be if you were to take the midpoint and find the highest point, the maximum value, that would be the amplitude. And because that's the midpoint, it's also true to the lowest value. This is also our amplitude. So to find their amplitude, we are going to take the difference between our maximum and minimum value and divide by 2. So 4 minus 0 divided by 2, and that is just 2. All right, next is period. Now period is quite important because since periodic functions repeat themselves, it's important to know how often they repeat themselves. So you can see right here is where we're starting, or we choose that as a starting point. You can choose it anywhere. And then here is where it ends and then repeats. And then here ends and repeats. So this distance here is our period. In this case, these numbers go up by 2. So from 0 to 2, 4, 6, 8. So just find the difference in those numbers. So 8 minus 0. And our period for this example is 8. Now the domain, as long as this repeats forever in both directions, then the domain is just all real values of x. The range will be all real values of y, but within our maximum and minimum values. So we have 0 is less than or equal to y, which is less than or equal to 4 for all real values. Okay, how's that? Not too bad. Let's see if we can identify these features for our other two examples. So first, maximum value here. This looks to be right here, which has a value of 1. So max equals 1. Okay, well, what's our minimum value? Minimum value is down here at -2. So our amplitude then, just call it A. Find the difference, so 1 minus -2, and divide that by 2. So double negative, so that becomes 3 halves. Our period, okay, we can pick a point. So if we like, we can start, let's start here at 0. That would probably be easy, I think. And then go over to where we repeat, which would be here. Okay, so 0 to 3. Okay, so 3 minus 0, which is just 3. Our domain is all real values. Forgot to do my, there we go. And our range is going to be between -2 and +1 for all real values. All right, not so bad. Let's do one more and then we're going to try something else. So for this last one, our maximum value is up here. Now here's where the 0 mark is, and these numbers go up by 2. No, it's hard to read. So 2, 4, 6, and then 7. So the maximum value is 7. And the minimum value goes down to -1. So that means our amplitude, which is 7 subtract -1, which would be 8, divided by 2 is 4. Our period, well, let's pick a point. 0 would be right here, so I'll pick this point. We'll go from here to here. So it looks like we're going from -2 to +2. So our period would be 2 subtract -2. Just find the difference. So our period is 4. Domain, all values for x, assuming it keeps going unless stated otherwise. And our range will be between our max and min. So greater than our minimum, but less than our maximum for all real values. All right, not so bad. Let's do one more thing. So because a periodic function goes on forever, if we know certain values and their period, then we can figure out the value at any point. So what does this mean? That means the function at some value x will be equal to that function at x plus k, which is some integer. Okay, so not a real number, an integer, times by the period p. Okay, let's try an example of what this means. So in this question, we have a periodic function, f at x, has a period of 9 units. So that means that this would be equal to f of x plus 9k, where k is just some integer. If f at 5 is -4 and f at 8 is -5, determine f at 41, at +41. So how can I rewrite this in this form? So this will be equal to f at x plus 9k. Okay, so plus 9k. So does 9 go into 41? No. The closest number to 41 that's less than 41 would be 36. Okay, 9 goes into 36 4 times. So this would be f of what plus 36, which is 9 times 4. Okay, so what plus 36 gives us 41? It's 5. So that means, according to this formula, this is equivalent to f at 5, which we know the value to be -4. All right, let's try another one. So 59. Does 9 go into 59? No. However, 9 times 6 is 54. So this could be equal to f plus 54. Okay, so what plus 54 gives us 59? It's 5, which is the same as f at 5. So its value is also -4. Well, what about 71? 9 doesn't go into 71, but it does go into 63. That's the closest to 71 that's less than 71, so plus 63. Okay, so I can write this as 8 plus 63. And so that's going to be the same as f at 8. And we know the value of f at 8. It's right there. It's -5. Well, what about this one? F of -1. Well, again, we just need x plus 9k. Okay, k is an integer, so it can be negative. I could make k -1. And if k were -1, this would be equal to f at something minus 9. Okay, what minus 9 is equal to -1? Well, 8. So that's the same as f at 8, which has a value of -5. All right, I hope this tutorial helped. If you have any questions, let me know in the comments. And if you're taking grade 12 physics soon or later, for a limited time, you can download my entire course pack that I give to my students for free in the description. Take a look, and thanks for watching.